Thank you so much for joining. It is amazing to be here. My name is Chinmayee Paunikar. I am joining from Boston, Massachusetts. I am a senior cybersecurity analyst at Fractional CISO, and I help organizations manage their cybersecurity and compliance programs. Before I go any further, I'd like to thank the team at Day of Security for doing such a fine job with this conference and for giving me this amazing opportunity to present in front of you all. Today, I'm going to talk about disaster response in the SaaS environment. So I want to take a minute and acknowledge how great it is that we can all gather here from the comforts of our homes. I, for one, love that I didn't have to drive or take the train, no bus rides either. I didn't have to Google Map the venue ahead of time, so I'd make it in time. This is perfect. Except I cannot share my slides part, but yeah, it's still great. Anyway, so on the Google Maps note, I have no idea how people got anywhere without Google Maps. I hear that they printed out something called a MapQuest, whatever that is. But if you don't know, look it up. It's this primitive thing that people used when there was no Google Maps. As a kid, I always just assumed that adults knew all the directions and that one day I would too. Boy, was I wrong. Today, I am so heavily dependent on Google Maps that if I don't have it, maybe my phone has no charge or just poor internet connection. If I don't have Google Maps, there is a huge possibility that I will keep going around in circles. I would be lost, or worse, I would be late, and that would be a complete disaster. Now, to avoid that disaster, I have kind of a continuity and recovery plan. I would ask someone for directions. That may not always work, so I would carry a portable charger. So why do you need to plan for disasters? Having a plan generally allows you to respond to a problem quickly and to limit its impact. Generally, the bigger a problem, the more important it is to have a response plan in place. It's very important for businesses to have a continuity and recovery plan for business-stopping circumstances like natural disasters and cyber attacks. And of course, like the plan can't be, we're gonna just run around screaming for help. There was a great comic here. You guys are missing out, but anyway. Okay, let's do a quick recap of the history of DR. Before the 1970s, most businesses held paper records. The 1970s saw the emergence of the first dedicated DR firms. Hot, warm, and cold sites came into being. Businesses could now duplicate the company's entire infrastructure if required. The 1990s saw the development of three-tier architecture that separated data from the application and user interface. And that made data maintenance and backup an easier process. The 2000s saw server virtualization. Virtualized servers could be restored in a matter of hours because businesses no longer needed to rebuild operating systems, servers, and applications separately. The 2010s saw a rise of cloud computing, and the software business has been in flux ever since. SaaS platforms have made it so that data is replicated within minutes of the production system and can be running as a live system within minutes. So in 2021, the work and prep for DR is low, but it's not zero. If you're relying on your SaaS provider's native security tools, you may be asking for trouble. Disaster recovery in a cloud environment may not mean how you deal with a failover, but how you deal with data corruption and loss. Your data may be safe, but did you consider human error? What if somebody accidentally deleted important files? What if someone overwrites a document? What if they download viruses? Or what if the cloud servers have an outage? And these are just some things that could happen accidentally, not even exploring the dark world of malicious attackers. One can argue that the SaaS vendor has a recovery solution. Sure, but is it fast? Is it easy? What about the cost? And will the recovered data be in a useful format? You may believe that you don't need to worry about disaster recovery since you don't own servers anymore. Today, most organizations have a DR plan that is AWS, Google, Azure, any other cloud provider will take care of it. Another argument I sometimes get is if AWS or Google or Microsoft are down, the world would have bigger problems to worry about. Yes, that's true. But you would want to do everything you can to avoid revenue losses, retain customer trust, and ensure your business's survival, right? A cloud platform's localized loss may not affect all their customers, but it could affect your business. So if you want to mitigate risks to your business, have a plan in place for cloud outage scenarios. What could go wrong with relying on your cloud provider? High-quality SaaS solutions provide robust security measures to protect their customers' data, but there may be circumstances that allow your SaaS provider to pass the buck to you. If you read your cloud provider's compliance reports carefully, they state something like, customers are responsible for developing their own disaster recovery and business continuity plans that address the inability to access or utilize our services. So in that case, you better have a backup plan in place because they don't have to help you. Cloud outages are very much a part of everyday life. I kid you not, just a few hours ago, there was some chatter in one of my groups that Google apps were not functioning. They were crashing on my friends' Android phones. 2 weeks ago, Azure was down. Earlier this year, Slack was down. Then Google Cloud Platform was down for some time. And this is just in 2021. All this has been happening, I guess, since cloud has existed. Cloud services are having some issues every now and then, and so many big companies rely on cloud services. Companies like AccuWeather, Coca-Cola, DocuSign, Vodafone, Walgreens rely on Azure. Disney, Adobe, Airbnb, Reddit, Unilever use AWS Cloud. And of course, Netflix, the star of the show, Netflix. I'll talk about them in a few minutes. Today, I'm going to focus on the AWS outage of 2011. You can only imagine the amount of chaos it caused. Amongst the ones affected were social media hubs, Reddit, Quora, and Hootsuite. They were taken offline for several hours. The AWS issue wasn't completely resolved, and even more than 24 hours later, the services were still degraded. Please note that I did not mention Netflix in the list of affected companies. I will talk about them. So Reddit was down, or at least degraded, for 36 hours. It's not that AWS isn't to blame, but there are a few things that Reddit could have done better. For instance, they were using a single elastic block store or EBS disk to back up some of their older primary databases. They also acknowledged that their code was written with the assumption that there would be only one data center. In short, a single point of failure. If Reddit had a plan in place, their operations might have been less affected. Now let's compare Reddit's outage response with Netflix. Netflix, by the way, uses, or at least at the time used, AWS for nearly all its computing and storage needs. But they had a very different outcome. The company saw a higher than usual error rate and higher latency, But the outage did not affect their customers' ability to find and start movies, nor did they see a noticeable increase in customer service calls. So, in a practical sense, Netflix was entirely unaffected by this outage. What was the difference? The difference was that Netflix had designed their systems to explicitly deal with such failures. They had Chaos Monkey to simulate failure. Chaos Monkey is a service that kills other services. It works by intentionally disabling computers in the production network to test how remaining systems respond to the outage. And that is what prepared them for random instance failures. Chaos Monkey actually helped jumpstart a new engineering practice called chaos engineering. It is exactly what it sounds like. You intentionally create chaos by injecting failures and errors in software during production. And then you monitor the effects to see how the system responds to stress. It's a great strategy for discovering vulnerabilities in a distributed system. In 2011, inspired by the success of the original Chaos Monkey, Netflix added a series of tools known as the Simian Army. The Simian Army is open source and consists of all these monkeys or tools ranging from Chaos Monkey to Janitor Monkey and Conformity Monkey. And they all provide different functions. Chaos Monkey handles terminations of random instances. Janitor Monkey ensures that the environment has no clutter and waste. Conformity Monkey ensures that non-adhering instances are terminated. Latency Monkey ensures that the system withstands a delay in the network. Doctor Monkey detects unhealthy instances, and Security Monkey ensures that securities are in place. Now let's take a deep dive into Netflix's secret for uptime success. Netflix obviously has invested a great deal of resources into developing their disaster response plans. And we can definitely take some lessons from them when we are developing our own plans. Data stored across zones, which means using multiple availability zones for your most critical databases. This will ensure that there are multiple redundant hot copies of the data spread across zones. So if one zone fails, a failover is automatically performed to the standby databases. 2. N+1 redundancy. Designing cloud architecture with N+1 redundancy means allocating more capacity than is actually needed at any point in time. That gives you the ability to cope with large spikes in load. Definitely costs more money. However, it would make systems more resilient to failures. Stateless services. Stateless services don't track information from call to call. They are designed such that any service instance can serve any request in a timely fashion. Often, the complexity revolves around maintaining the session state, which means replicating it across the cluster. But with stateless services, there is no need to maintain a state. So when a server fails, it's not a big deal. The request can be routed to another service instance, and a new node can be automatically spun up to replace it. Take a note that the stateless approach may not always be right for your application, which could rule this option out. 4. Graceful degradation. Failure is not an exception in software, it is the rule. That is why graceful degradation is a key concept. It has been an important consideration in the design and implementation of large communication networks since Internet was conceived. The design philosophy of graceful degradation dictates that when some part of the system fails, you enable systems to continue their intended operation. The purpose of graceful degradation is to prevent catastrophic failure. If a service stops meeting its SLA, the calling services should resort to a backup behavior, and that will prevent failures from cascading. Okay, so that was the streaming giant's secret to their uptime success. But what if you don't have a plan at all? Where would you start? Start with a business impact analysis. Evaluate the potential effects of an interruption to critical business operations as a result of disasters, accidents, or any emergency. That will give you a clear picture of the criticality of your business operations and will help you identify the dependencies. Then you can use this information to build an effective strategy that addresses those areas that need to be recovered and the designated time frame in which to recover them. While most enterprises are not ready for the randomness of a system like Chaos Monkey or Simian Army, there are some takeaways from the concept that apply to traditional infrastructures. The key concepts are testing, automating zone failover and recovery, using multiple application servers, and multi-region support. Now let's walk through all of them. Testing. Performing tests of individual system outages is highly important. I cannot stress that enough. It's better to burn in a fire drill than an actual fire, right? The purpose of testing is to discover flaws in your DR plan so they can be resolved before they impact operations. Regular testing is the only way to guarantee that you can restore customer operations quickly following an outage. DR testing should be done at least annually. If you work with a managed service provider, you need to make sure that they have proof of your daily backups and make sure that the backup is functioning properly. Automate zone failover and recovery. Once you determine a priority order for your most critical applications, automate the recovery process to ensure minimum data loss. This would entail using tools and services that allow automatic failover to your standby systems. Look for other processes that may fail and can be automatically recovered. Automation will not only reduce recovery times, but will also reduce the need for human intervention and judgment. Multiple application servers. Deploying applications over multiple servers will keep applications running efficiently and reduce downtime. I'm sorry. I got distracted by the chat. Sorry. Multiple application servers will keep your applications running efficiently and would reduce downtime. Using multiple application servers would give you the ability to configure fault tolerance. More servers also mean improved scalability. This was a slide with the Lord of the Rings slide where you have Sean Bean going like this, saying, "You simply do not." Okay, the slide says, "Don't put all your eggs in one basket, because if the basket breaks, you're screwed." It's a classic slide. It's a classic meme. I love it. Okay, problem statement is that if you're hosting everything in the US East region, and due to some human error, maybe it goes down, and well, history has shown us that it can go down, then what happens? Yes, that is a problem. So don't put all your eggs in one basket, spread out. That will give you the ability to completely vacate a region if large-scale outage occurs. If your primary application is hosted in the US East region, and the secondary application is in the US West region, say, when the primary environment is compromised, you can still keep your services running. By an extension of the same logic, using multi-cloud disaster recovery and replicating your resources to a second cloud provider, maybe in another geographic region, will help you keep your things running. For example, if AWS ever goes down, you can pick back up easily in, say, Azure or Google Cloud. And don't forget to test everything out. Lastly, law, right? Anything that can go wrong will go wrong. So if you ever want to avoid saying everything that could go wrong went wrong today, have a plan. Disasters don't happen very often, but unfortunately, they usually happen at an inconvenient time with little or no warning at all. It's important to plan for outlier events and put thought into what to do when, not if, when a component fails. DR in 2021 can be thought of more as a thought exercise that you do to cover all the possible, if not plausible, disasters. Think of it as a very specific type of emergency response. So it can be the final chapter of your incident response plan instead of being a whole new book. I don't ever want to be late to a meeting just because Google Maps won't work, but I have a plan. Your company needs one too. Thank you so much for your patience. And this did not go as I expected because slides, but was still great. I'm gonna look at any questions if you have. Would love to connect with you all on LinkedIn, and if there's anything you guys want to know about my job or anything about what my company does, would be more than happy to chat on whichever platform you prefer. Again, thank you so much for your patience. I had a great time presenting to you all, and hopefully we'll connect with you and speak with you guys soon. Thank you. Thank you, Audrey.